In this video, we are going to talk about multiple linear regression. So first, let's start with the problem description that we have. So suppose you work for an MNC and you are given this data that contains the R&D spend, the administration spend, and the marketing spend of an MNC, and the state where the office of that MNC was located. For example, New York, California, and Florida. And then you are also given the profit that each of these individual offices made of an MNC. So you are given this data and you are said to find out the profit if some values of R&D spend, administration, marketing, and state was given. So this is the problem description that we have. So let's jump into the code. Okay, so we'll start by importing the libraries. So we are basically using four libraries. So we importing NumPy, Matplotlib, and Pandas. So NumPy is basically used to deal with arrays, and Matplotlib is used to plot the graphs or anything visualization that you want to do. It's done using Matplotlib, and Pandas is basically used to access the dataset. And one more library which we'll be using is scikit-learn, and I'll be importing that further down the code. So now the next thing is to import the dataset. So we'll create a variable called dataset, and then we'll write pd dot read underscore csv. So pd is nothing but pandas because we imported it as pd. So we're going to use pd everywhere instead of writing pandas. So we'll import the dataset. It's called 50 underscore startups.csv. Now we'll split the dataset into two parts, namely X and Y. So, so X is basically the independent variables. As you can look here in the code, the R&D spend, the administration, the marketing spend, and the state. All these things come under independent variables, and profit is our dependent variable. So we're going to import all the rows which we represent by a colon and all the columns minus 1 because we want to only take the independent variables from R&D spend to state. So we'll write here minus 1, and for the dependent variable we'll use minus 1 over here to access the profit column. Okay, so now let's run each and every cell. Okay, so as you can see, now we can also print text to see what values were selected. So as you can see, this was the R&D spend, and this would have been the administration, and this would have been the marketing spend, and the state where the office is located shown here. So the next thing we need to do is encode the categorical data. So uh, just for your understanding, a machine learning model cannot work on alphabets. A machine learning model can only work on numbers. So it doesn't understand what's New York and what's California or what's Florida. So we need to encode them into numbers. But we cannot use 1, 2, 3 because then our model might make some connections between 1 and 2, thinking that if I assign New York as 1 and California as 2, then it might think that okay, California is 2 times better than New York. So we have to encode them in such a way that they retain their individuality and not get mixed up in the machine learning algorithm. So for that, what we do is we use column transformer and one-hot encoding. So basically we are using the scikit-learn library, and from the compose module we are importing the column transformer. And similarly from sklearn.preprocessing, we are importing one-hot encoder. So what one-hot encoder basically does is it will provide the value. So we have like three different states, for example, New York, California, and Florida. So what will what will it do? It will assign 001 to New York and 010 to California and 100 to Florida. So that way they will retain their individuality, and at the same time we'll be able to put them into our machine learning model. Okay, so now to encode the categorical data, we will just take a random variable ct column transformer and then import the column transformer function, and inside this function we'll write transformers equal to encoder 1 hot encoding and 3, because we have three different values which were New York, Florida and California, and we'll also use remainder equal to pass through. Okay, just to correct myself, we used 3 here because the y column which we wanted to, sorry, the independent variable which we wanted to transform was in the third position. So as you know, in Python the indexing starts from 0, so R&D spend would be 0, administration would be 1, marketing spend would be 2, and then the state column would be third. So this is the reason why we are using 3 here, and not because that we have three different states, because if we even had 5 or 6 different states, still we would be using 3 here and not 6 or 7. So then what we'll do is we will assign these values to our x. So we'll use numpy's np dot array function, and we'll use fid underscore transform. So what it does, it fits the value of ct into the existing values of x. So what will it do is it will replace the values of x, which was here. So it will replace the value of New York with the one hot encoded characters. So let's see how this works. I'll just run it and then print x. So encoding takes somewhat time to do. So as you can see here, we got print x, and when you look at it, see, you can't see anything like New York, California, or Florida. But what I can see here is 0, 0.0, 0, 0.0, and 0 and 1.0. So it corresponds to the first value. So let me go to the startups. So the first state was New York. So basically it has given the value of 001 to New York. And similarly for the second one, it was California. So it has given the value of 100 to California. So this process is somewhat random, and you can also choose how it's done, but it would take a lot of more code. But from this we can find out which value is what. So for example, we know that New York is 001 and California is 100, and therefore Florida would be 010. So now let's go back to splitting the data set into training set and test set. Okay, so we'll be using the train test split function from the model selection module of the sklearn library. So this step I already told you how it's done in the previous video, so I won't be taking much of your time. The only thing different here is that the test size we are taking here at 20%. So for example, if we had 100 observations, we'll only use 80 observations to train our model, and the rest 20 would be used in the test set in order to find the accuracy or to just to predict the test set results. And we can set random set equal to 0. You can change this value if you want, like you can put it to 69. It will still work. It's just that your values would be, you will get some random values now. So the next thing is training the multiple linear regression model on the training set. So see, there is no special function for multiple linear regression. It is just that we had more than one independent variable. So if we apply linear regression to more than one independent variables, it automatically becomes a multiple linear regression problem. So the next thing we are going to is initialize the regressor using the linear regression parenthesis, and then we are going to fit the data x train and y train into the regression model. Okay, so our model is trained now. So now let's see the test set results. Okay, so to predict new values, we have to use this predict function that we have in the regressor function. So we are going to input the value of x test, and from this x test, we are going to predict the values of y pred. Now remember, for the values of x test, we already have the values of y test. So we know what the answer of x test should be. The answer of x test should be y test. But we are checking if our model can be somewhere close to those values. So we are using a different variable called y pred. And then we will compare the values of y test and y pred. Okay, so the next line of code is np.setPrintOptions precision equals to 2. So what we're doing here is the predicted value that comes out of this regressor in ypred. So we are setting it to a precision of 2 decimal places. So as you can already see here, the precision is set to decimal places like 0.38, 0.95, 0.83. So this line is just to that make sure we don't get somewhat a bigger value in terms of numbers, because anything after the point is more or less meaningless in this case. So the next thing is to print out the y pred and the y test. So what we are doing here is we are using np.concatenate. So what concatenate does it merges two different rows or columns. So first column would be the y pred, and we are going to reshape it so that it becomes vertical using this one function. And we are doing it so that we can easily distinguish what the y pred was and what the y test was, to see how good our model did. And similarly, we are going to use the y test dot reshape here, and we are going to set it vertical as well. And then we are going to concatenate it vertically. So what it does is, the first thing, this was converted into uh, vertical, and then this thing was converted into vertical, and then we concatenated it vertically. So we got this output. So let's run this code and see what happens. So as you can see, we are getting these values. So the values change because above here I changed the random state. So if you want, you can choose any random state you want, and you will get new values each and every time. Okay, so the y predicted value for some particular uh, x train and y train when it was trained on that and used to predict x test. So some for some particular x test, the predicted value was 173,586, and the actual value of that x test was 166,187. For the next one, it was 86,857, and the true value of that particular X test was 96712. So as you can see, our model did pretty well in this case. As you can see, in the first case, the difference is only around 7,000. In the second case, it's around 10,000. As you can see, in third case, it's again around 10,000. In the fourth case, it's around something like 10,000 again, 10,000 or 9,000. So this is how we are going to predict the tested results. But what if somebody asks you about a completely new data? So how we are going to predict the profit out of that? So for that, we'll be writing that complete value of the X train that we put here, or rather than X test. So X test contained, let me go up here and show you. So basically our X contained the encoded variable, the R&D spend, the administration and marketing. So for example, if I say to you, uh, I want to find the profit of the office located in California. So first I have to find out the encoded variable for it. So I believe California was the second one. So California is 100. So what I'll do here is I'll just write here 100, and then let's just say I said the R&D of that particular office was 1600. So, or rather than, let's say, 1,60,000. So, and the administration was like a bit low, and let's say only 1,300. And the marketing spend was let's just say it was 30,000. So I want to predict a new value on how much the profit of that particular office would be. So we'll encode it in two of these square brackets, because see, individually x had two brackets, so its dimensionality here is 2. So we need to put two square brackets over here, because these two square brackets combined make up to one particular value of the x test. So now we are going to run this code. So see, we are getting the profit of around 1,89,569. So basically, there's no way to check if this thing is correct or not. So, but we are predicting that if we spend this much amount of money in the California office, our profit will be this much. And as we can see from the above observations, that we are almost very close to the true values. So plus minus 10,000 or 20,000 would be at max the error in this code. So this is how you can use multiple linear regression for such a problem. If you are given more than one independent variables and you have to find one dependent variable, then I believe multiple linear regression is a good choice. So I'll see you guys in the next video. Thanks.